So this problem is involving two piecewise functions. So let's do the two functions. So we're going to do t of x is the piecewise function for TM trucking. Now it is $120 for x less than or equal to 100 miles. If we go over that, it's a little bit trickier. We know our slope is 50 cents a mile. So the slope is 0.5. We need to find the y-intercept. Well, we know our equation is going to have the form y equals 0.5x plus b. We need to have a point that goes through. Well, the point that it goes through at 100 miles, the price is still $120. So if x is 100, y is still 120. It has to be that end point, the very end of this range, because that's where that line starts to slope up from. So let's put that in here and see what we get for an equation. So we get 120 here when x is 100 plus b. So 120, 0.5 times 100 is 50, plus b, subtracting is going to give us b equals 70. So the equation up here is y equals 0.5 times x plus 70 if x is greater than 100 miles. So that is the function, the piecewise function for TM. Let's call our function L of x for LX trucking. Their cost is $80 for x less than 60. If x is more than 60, it's 75 cents per mile. So we know that is going to be y equals 0.75 times x plus whatever that y-intercept turns out to be. We know that one has to go through the point $80, when x is 60, y is 80. So let's substitute in that point. So 80 equals 0.75 times 60 plus b. 0.75 times 60 is 45. So subtracting to get b, subtracting 45, we get 35 is b. So that makes that equation, filling in 35 for b, y equals 0.75x plus 35 if x is greater than 60 miles. So what we're looking for here, hopefully, if we were to graph these, and we really should graph them to double check, TM is going to look like this and slope up and slope up. LS is going to be lower. It's going to start sloping up sooner and a little bit steeper. They will cross over here in the slope sections. To double check, let's make sure that LS doesn't hit that $100 before, or that $120 before it gets past the 100 miles. If I put 100 miles in here, that's going to be in this formula. If I put 100 in for x, 0.75 times 100 plus 35, that ends up being 75 plus 35, which is $110. So that does not exceed the 120. That's telling us that these lines will not cross until both of them are sloping. The reason we needed to know that is now we know what two things to set equal. We have to look to see where this system of equations is solved. Our two equations, 0.5x plus 70 and 0.75x plus 35. We have to put our y variable in here. Y equals 0.5x plus 70 and y equals 0.75x plus 35. So now we're going back a few weeks before our first exam. This is solving a system of equations. This is a case where we can just do substitution. Both of these are solved for y. So what I can do is plug this into this one in place of y. So we get 0.75x plus 35 equals 0.5x plus 70, and we solve. First step, there's nothing to combine on either side. So that's done. Second step, the x is on both sides, so we're going to get rid of the smaller one, subtracting 0.5x. That gives us 0.25x plus 35 equals 70. Now we'll go ahead and solve by taking this apart. Subtracting 35 gives us 0.25x. 70 minus 35 is 35. And dividing by 0.25 gives us that x is 140. So at 140 miles, those two rentals are equal. Did anybody come up with that? Is anybody confident they were heading in the right direction, just needed more time? Okay, that was a tough one to throw at you. Does anybody have questions on how I got to what I did now that you've seen it done? Okay. I'm not saying I would do that to you on the test coming up. I just wanted you to see how these concepts do all fit together at some point and work together for applications. So that was one of the things we did on Tuesday, yesterday, was we dealt with those piecewise functions. But we also started talking about the generic form of a lot of equations. You know, we talked about lines having that generic form of y equals x. And we did things to modify that line, things like slope and y-intercept. But another form that we used for those lines was we used point-slope form of an equation. If you recall, the point-slope form of an equation said, if we have the slope of the line and a point it goes through, the equation is y minus y1, which is that y-coordinate in that point, equals our slope times x minus x1. So if we have a line that has a slope of 1/2 and goes through the point 5, 2. What this equation looks like is y minus 2 equals our slope of 1/2 times x minus 5. Essentially, what this has done is it's shifted the origin of our graph. If we think of a line that starts out as simply y equals 1/2 x. So it's a line with the same slope as what we're looking at, slope of 1/2, but it goes to the origin. That line is going to look something like this. Well, what this is telling us to do is shift the origin from x equals 0 over to x equals 5, and from y equals 0 to y equals 2. So x equals 5, y equals 2 is right there. And the line actually goes through that point is the origin. So that green line is actually the graph of that equation. Now we've been talking about functions. So we prefer to we've started using that function notation on our equations where it's f of x or g of x, whatever letter we're using for our function equals that function. So having y minus 2 over here isn't going to work for us. What we're going to do is rearrange that. We're going to add 2 to both sides. So this is y equals 1/2 times x minus 5. And now that minus 2 becomes a plus 2 on the other side. So in function form, this is f of x equals 1/2 times x minus 5, then plus 2. If I have f of x equals negative 2/3 times x minus 3 plus 4, that's telling us that that line goes through what point on my graph? 3 and 4. Very good. Right there. And it has a slope of negative 2/3. So down 2 over 3. There's my line. If I give you f of x equals 2 x plus 1 plus 3, that's telling us that that line, that graph goes through what, or that line goes through what point on my graph? Negative 1, 3. Very good. Because it's the opposite of this one.
So if it's in the parentheses, it's the opposite, basically?
Yep. What's in the parentheses with the x is the opposite. That's plus 1, so that means it's x is negative 1. What's out here is just the y coordinate. Remember, that really should be minus 3 over here with the y, but we moved it over so we could use the function notation. So yeah, negative 1, 3 is right there, and the slope is 2, so we go up 2 over 1, giving us that line. One more I want to show you. F of x equals 1/2 x minus 2 minus 3. What line on this graph does that equation go through? Or what point on the graph does the line of that equation go through? 2, negative 3. Very good. Positive 2, negative 3. And of course, that has a slope of 1/2. So up 1 over 2 puts us something like that. The reason I went over this with lines, it's not nearly as useful with lines as it is for other graphs, is it actually does allow us to find shortcuts for graphing other types of graphs. For example, we talked about parabolas. Parabolas come from what's called quadratic equations. Won't mix my cursive with my printing. Quadratic equations. Quadratic equations take the form of y equals x squared. X squared is the largest power they have, and all powers are integers, or sorry, I should say whole numbers. Can't be negative. So in other words, it can have an x and it can have an x squared, and that's it. Can't have any other powers of x. The graph for that, as we explored a little bit yesterday, looks like this. The vertex is at the origin. If we go over 1, 1 squared is still 1. If we go over 2, 2 squared is 4, so that means it goes up 4 units. If we go over 3, 3 squared is 9, so it goes up 9 units. Same happens on the other side. Negative 1 squared is 1, negative 2 squared is 4, negative 3 squared is 9. We get that parabola. Looks just like that. And remember, this point right here is called the vertex. The vertex is at the origin. So to be consistent with what we learned with our lines, given this equation here, y minus 2 equals x minus 5 squared, the origin is going to move to what coordinate?
5.
X is 5 and y is 2. So the vertex of that parabola moves to 5, 2. The rest of its shape stays the same. Now, once again, in order to use function notation, this often gets rewritten as f of x equals, we add the 2 to put it to the other side, x minus 5 squared plus 2, like that. So if I have an equation, f of x equals x minus 3 squared minus 1, where's the vertex of that parabola going to be? At 3 for x and for y? Negative 1. Very good. Because whatever happens over here is the y coordinate. The opposite of this is the x coordinate. So it's minus 3. The x coordinate is positive 3. This is minus 1. The y coordinate is minus 1. Then, of course, it looks the same going up from there. Let's see. F of x equals x plus 5 squared plus 1. Where's the vertex of that one going to be? Negative 5, positive 1. Very good. It's the opposite of this for the x coordinate and this number for the y coordinate. Now, you heard me mumble a little bit as I graph this. Once you've located the vertex on these, finding the other points are fairly simple. Because this is x squared, it's a squared. If I go over 1 unit, what's 1 squared? 1, so I go up 1. Starting back at the vertex, if I go over 2 units, what's 2 squared? What's 2 squared? 2 times 2. 4, so I go up 4. If I starting back at the vertex again, if I went over 3 units, what's 3 squared? 9. So I go up, pretend that's 9 units. That'd be the next point. And it's the same on the other side. Going back 1, negative 1 squared, of course, is 1. Going back 2, negative 2 squared is 4. Going back 3, negative 3 squared is 9. So I want you guys in your notes to try to graph this. F of x is,
For that last one of infinity, negative and positive.
what's that?
Would the domain for that have been negative infinity and infinity?
Ah, good question. The domain for this, you are absolutely correct. It goes from negative infinity to positive infinity. What would the range be?
Let's see. You only can go to what, 1? So 1 negative or 1 in infinity?
1 to infinity. What bracket goes with the 1?
Squared.
Yeah, that's going to be squared because it does equal 1. Very good. So in your notes, I want you to graph f of x plus 2 squared minus 3. Do a quick sketch of that graph. So the vertex is going to be where?
Negative 2,
-2, -3. Very good. And of course, over 1 up 1, over 2 up 4, over 3 up 9. Same on the other side. Any questions on why I was getting that up 1, up 4, up 9? Because it's x squared, it goes up. 1 over is 1 up. 2 over is 4 up. And 3 over is 9 up, so on, because of the squared. Well, let's look at some other forms of equations. Y equals the absolute value of x. We saw yesterday that this forms a V on our graph. That we could actually turn this into a piecewise function. That it would be f of x equals x if x is less than or equal to 0, and if negative x if x is less than or equal to 0, and x if x is greater than 0. We got those two lines. The point of that V, again, the vertex of the graph is at the origin. So for this, y minus 3 equals the absolute value of x minus 2, where would I expect the vertex of that V, of that graph, to be at? At 2, 3. Very good. So we go over 2, up 3. There's the vertex of that graph. Like that. Well, again, we're using function notation, so we would add 3 to both sides to get that would be written as f of x equals absolute value of x minus 2 and then plus 3. So if I had f of x equals, I'm going to slide this over a little bit, absolute value of x plus 1 plus 2, where would I expect that vertex to be? Negative 1, 2. Very good. It's the opposite of this one. So that's plus 1, so x is at negative 1. And it's the same as that one, plus 2, so y is at positive 2. So negative 1, positive 2. There's that graph. So in your notes, I would like you to sketch the graph of f of x equals the absolute value of x plus 3 minus 5. So where's our vertex at? Negative 3, careful. Negative 3, negative 5. Since it's on this side, now that is the opposite. It's the same as that one for the y. So the vertex is right there, negative 3, negative 5. Of course, it has a slope of 1 on each side. Each of these graphs can be affected in other ways. That's called translating the graph, or translating the origin in this case for these graphs, by moving it over and up, or down, of course, horizontally and vertically. We can also adjust these graphs by reflections. What a reflection would be let's say the graph looked like this. A reflection could either be about the y-axis. Well, the y-axis is this one, so that means every point that's on this side gets moved over to the other side the same distance away. So that would look something like that. Or it could be reflected about the x-axis. Of course, this is the x-axis here. That means every point above the axis gets moved to below the axis, and vice versa. Every point below gets moved above. So back to that black line, there's our original graph. The reflection about the x-axis would look something like that. So now, algebraically, how do we make those happen to each of our graphs? Let's look at reflecting about the y-axis. This is the most common one usually used. So reflecting about the y-axis, a point that is above the axis now becomes, the point that's on the right side of the axis is now going to have its image on the left side of the axis, on the other side. So if this point here, what would be the coordinate of this point? Three, 6. And how about the coordinate of this point, the reflection? Negative 3, 6. What changed about the coordinate? Yeah, x. X became negative x. So to reflect around the y-axis, we actually multiply by the x by negative 1. So if we have y equals x as our line, the reflection about the y-axis is going to be y equals negative x. I'm sorry. Got to be careful. I got to pause for a second. So what I really should do is this. Rather than using y equals x as my notation, I should use this. F of x equals x. And to reflect about the y-axis, it becomes f of negative x. What does that mean? Well, what that means is let's do a graph of a line here. F of x equals 2/3 x minus 4 plus 1. So what that is telling us is this graph goes through what point? 4, 1. Right there. And it has a slope of 2/3. Oops. So it looks something like this. F of negative x would look like this. Replace x with negative x. What we have to do is factor out, because this needs to be x here, we need to factor out a negative 1 from this parentheses. If I factor out a negative 1, I'm going to let g of x equal that function. G of x, the negative 1 goes with the 2/3. This is now negative 2/3 times x plus 4 plus 1. So what's changed here? Well, this goes through not 4, 1, but negative 4, 1. And the slope isn't 2/3, it's negative 2/3. Now you will notice, so this is reflected about the y-axis. Notice that the y-intercept is the same for both of those lines. Y-intercepts will not change. Points that are on the y-axis will not move. Because if they're on the axis, when you reflect them about the axis, there's no place for it to go. So if we have f of x equals negative 2, x minus 3 minus 5, what would be the equation? I'm going to find g of x, where g of x is a reflection about the y-axis. I'm going to give you a second to try that, and then we'll do it. So for this reflection around the y-axis, g of x, that reflection, is going to equal to f of x negative 1, which is what we get if we put f of negative x. So that equals negative 2 times, instead of x, we put in negative x, minus 3, and then minus 5. Then to simplify this, we factor out the negative 1 here to get what? 2 times x plus 3 minus 5. Very good. So for this one, f of x equals x minus 4 squared minus 1. Of course, the vertex of that, it's a parabola. The vertex is going to be at what coordinate? 4, negative 1. Very good, right there. If this is reflected around the y-axis, that vertex, of course, has to move to what point? Remember, it's the x-coordinate that has to change, so it's going to have to move to negative 4, negative 1. It's still going to go upright like that in the same width. So for that reflection, if we let g of x be that reflection, that's going to equal f of negative x again. Looking here, we've got negative x minus 4. We need a positive x in there. We can't just factor out the negative 1 because it's squared here. What we can do is this, however. Imagine that being in other parentheses. If I factor out the negative 1, so it'll be negative 1, and now that does become x plus 4, positive x plus 4. And that's all squared. So what this is saying is the x plus 4 is still squared, but the negative 1 is also squared. What's negative 1 squared? Just 1. So f of negative x, or g of x here, just makes this x plus 4 squared, and then minus 1. Note that would give us that equation, or that parabola on the graph. If I have h of x equals x plus 1 squared minus 3, to reflect that about the y-axis again, we'll let m of x be the reflection. I'm just going to put about y-axis, like that. M of x has to equal h of negative x. So we're going to put negative x in where x is. It's going to look like that. Well, we're going to do the same thing to simplify this. We have to take this here and factor out a negative 1. So negative x plus 1, if I factor out a negative 1, what am I left with? Positive x minus 1. Good. And of course, in the process of squaring that, the minus 1 becomes positive 1. So this is just going to be x minus 1 squared minus 3. Does that make sense? Realistically, I didn't have to go through all of this work here. I just have to realize that when I reflect about the y-axis, whatever this is, I change it from a plus 1 to a negative 1. So if I give you p of x equals x minus 2 squared minus 4, find t of x, which is the reflection about the y-axis. What do we get that to be? X plus 2 squared minus 4. Good. What if k of x equals x squared plus 7? Find L of x, which again is the reflection about the y-axis. What are your thoughts? Exactly. We can think of this as being x minus 0 squared plus 7, right? Well, x minus 0 and x plus 0 are the same thing. It's just x. So reflected about the y-axis, that is still itself. The reason that one doesn't change is because x squared plus 7 looks like this. Its vertex is at 7 and it goes up like that. Its vertex is on the y-axis. It is symmetrical about the y-axis. So if it's symmetrical about the y-axis, if I reflect it, I'm flipping this side to there and that side to there, it falls back on itself. That's what symmetry means, is if it's reflected about that axis, it reflects onto itself. So yes, in this case, the reflection about the y-axis is the exact same equation because it's already symmetrical about the y-axis. So given that, f of x equals the absolute value of x, if g of x is the reflection about the y-axis, what's the equation for g of x? Yeah, the absolute value of x. It's the same thing. Because the absolute value of x, the graph for that is just this. It's already symmetrical about that y-axis. So its reflection about the y-axis is going to be the same thing. If f of x equals x minus 3 plus 1, where's the vertex of that parabola going to be? Positive 3, positive 1. Very good. If I reflect that about the y-axis, where does its vertex have to be? Negative 3, positive 1. Very good. Notice it's still going to cross the y-axis in the same spot. The y-intercepts won't change. Points on the y-axis will not change. How do we get that to work? Well, if g of x, again, is that reflection about the y-axis, it equals f of negative x. If I put negative x in for x here, it's negative 3, or negative x minus 3 plus 1. Well, again, if I enclose that in parentheses and I factor out the negative, negative 1 equals, or negative 1 times x plus 3, right? Well, this is an absolute value here. So this is saying the absolute value of negative 1 and the absolute value of x plus 3. What's the absolute value of negative 1? 1. So g of x is just the absolute value of x plus 3. So just like with our parabolas, what changes here is that this went from minus 3 to plus 3. So if we have f of x equals the absolute value of x plus 7 minus 4, let g of x be the reflection about the y-axis. What's the equation for g of x going to be? There you go. G of x will be the absolute value of x minus 7, then minus 4. So we have reflected about the y-axis. If I want to reflect about the x-axis, what that means then is any points that are up here moved down there. So it's now the y-coordinate that changes. If I have y equals x and I reflected about the x-axis, it's now negative y equals x. Now this is where I said earlier this doesn't make a lot of sense because, well, negative y equals x is the same as y equals negative x. So it makes a little more sense if we put it in function notation. If f of x equals x, the reflection around the x-axis would be negative f of x equals that function. So what this means, for a line, let's say f of x equals 1/2 x minus 4 minus 2. If I graph that, what point does that line go through? Careful. 4, negative 2. There we go. 4, negative 2, and occurs as a slope of 1/2. If g of x is the reflection about the x-axis, g of x equals negative f of x. What that means is I multiply this whole equation times negative 1. Now this equation right now only has two pieces to it. It has this piece right here, and it has this piece here. So when I multiply by negative 1, I only have to multiply, each of those pieces. So g of x, negative 1 times 1/2 times x minus 4, I just have to do negative 1 times 1/2 is negative 1/2 times x minus 4. How about negative 1 times negative 2? Positive 2. You'll notice two things have changed here from the original equation. Let's start with what has not changed, is the x-coordinate of that point it goes through. That's still positive 4. However, the y-coordinate has changed from negative 2 to positive 2. The second thing that has changed is the slope. You got it. It went from positive 1/2 to negative 1/2. So it now looks like this. Once again, note that this point here was on the x-axis. It didn't change. It didn't move. So it still has the same x-intercept. It crosses the x-axis at the same point. So if f of x equals negative 2/3 times x plus 1 plus 5, and if g of x is going to be the reflection about the x-axis, what this becomes, g of x has to change the slope. Negative 2/3 becomes positive 2/3, just 2/3. What happens to the x plus 1? Yeah, nothing happens to it. It stays the same, and then the plus 5 becomes minus 5. Very good. So if we have f of x equals negative 2 times x minus 3 minus 1, find g of x in your notes, where g of x is the reflection about the x-axis. What do we get? 2 times x minus 3 plus 1. Very good. Any questions on that? So let's look at parabolas. If f of x equals x minus 2 squared plus 3, where is the vertex of this parabola going to be located? Positive 2, positive 3. Very good, right there. If this is going to be reflected about the x-axis, right here, that vertex has to be down here, and it's going to have to open the other way. It's going to have to open upside down. So if g of x is that reflection, g of x equals negative f of x, which is negative 1 times this equation. Well, negative 1 times x minus 2 squared is just negative 1 times x minus 2 squared. We could leave it as just negative in front of there if we wanted to. Means the same thing. Negative 1 times the positive 3 becomes negative 3. So this is now telling us that the vertex is still at 2, negative 3, which is exactly what we predicted. Now we haven't talked about slopes of parabolas yet, but this negative up here, from what we can see here, is telling us that that parabola has to open downward. So if f of x equals absolute value of x plus 3 plus 1, where does that vertex have to be? Negative 3, 1, right? Reflected about the x-axis, that vertex is going to have to be at negative 3, negative 1, and it's going to have to open down like this. If g of x is that reflection, it equals a negative times f of x. That's negative 1 times absolute value of x plus 3 plus 1. Once again, negative 1 times the absolute value of x plus 3 is just negative 1 times the absolute value of x plus 3. Negative 1 times 1 is just negative 1. Now again, I could remove this 1 here and just put a negative in front of the absolute value. Does the same thing. I need to talk a little bit before we run out of time here about slopes for both parabolas and for the absolute values. Let's look at the parabola. We started out with y equals x squared. The vertex, of course, is at the origin, 0, 0. And we said to find the other points, if you move over 1, 1 squared is 1. So you go up 1. If you go over 2, 2 squared is 4, so you go up 4. If you go over 3, 3 squared is 9, so you go up 9. You get that side like that. And on the other side, it's the same. Over 1, over negative 1, up 1. Over negative 2, up 4, and over negative 3, up 9. Well, this can be thought of as having a slope of 1. It's 1 times x squared. If that were y equals 2 times x squared, it's technically not called a slope when it's on a parabola, but it kind of serves that same purpose. What happens now is all the rises are doubled. If we go over 1, 1 squared is still 1, but we have to multiply that by 2. So it's up 2. If we go over 2, 2 squared is 4. We have to double that, so we go up 8. If we go over 3, 3 squared is 9, but we have to double that, would be 18, which is going to be off our graph. And the same in the other direction. Back 1, negative 1 squared is still 1, times 2 is 2. Negative 2 squared is still 4, times 2 is 8. So you can see that parabola gets narrower. What if it were y equals negative 3x squared? Well, same thing. Vertex is still at the origin. If we go over 1, what's 1 squared? 1, right? We have to multiply that by negative 3, so we go down 3. If we go over 2, what's 2 squared? 2 squared is 4, times 3 is negative 12. Perfect. On the other side, the same thing. Back 1, negative 1. Negative 1 squared is 1 times negative 3, negative 3. Negative 2 squared is 4 times negative 3 is negative 12. So that causes it to open downward. So f of x equals 1/2 x minus 3 squared plus 1. The vertex is where? 3, 1. Very good. 1, 2, 3, 1, right there. Now, because of this 1/2 here, we go over 1. 1 squared is 1. We're only going to go up 1/2. If we go over 2, 2 squared is 4. 4 times 1/2 is 2. If we go over 3, 3 squared is 9. 9 times 1/2 is 4.5. So we go up 1, 2, 3, 4, 5, 4.5 is right there. Notice this is a much wider parabola. So over 1, up 1/2, over 2, up 1, over 3, up 4.5. Like that. For a absolute value. This one's a little easier to deal with. Y equals the absolute value of x, of course, has its vertex at the origin. And this side has a slope of 1. This side has a slope of negative 1. So it'd be pretty easy to imagine what this looks like. Y equals 3 times the absolute value of x. It's going to look something like this. What do you think the slope of this side is going to be? Well, instead of 1, it's going to have a slope of 3. And how about this side? Negative 3. Very good. So if I want to graph f of x equals negative 3/4 times the absolute value of x plus 1 minus 3. Where's the vertex of that? Negative 1, negative 3. Very good. On this side, what slope is that going to have? Careful. Negative 3/4, negative 3/4. So from this point, we go down 1, 2, 3 over 1, 2, 3, 4. There's my next point. On this side, it's going to have the opposite slope, a positive 3/4 slope. To find that, we're going to make it negative 3 over negative 4. So we're going to go down 3, back 4 to get that point right there. And there is our absolute value graph. So I want you to graph for me f of x equals negative 2, x minus 3 squared minus 2, and g of x equals 3/2 times x plus 2, or absolute value of x plus 2 minus 4. Have you graphed the two of those, and we will talk about them here in just a minute. So for this one, of course, what shape is it going to be for f of x? Parabola, good. Where is its vertex going to be? 3, negative 2, very good. Now from there, if I go over 1, 1 squared would be 1. How far am I going to go up or down? Well, I multiply that by the negative 2. So 1 squared is 1 times negative 2 is negative 2. So I go down 2. If I went over 2, 2 squared is 4, right? Times negative 2 would be negative 8. So from that vertex, I go over 2, I go down 8. Giving me that curve over there. On the other side, going back 1, well, negative 1 squared is still 1, times negative 2 is negative 2, so I go down 2. Back 2, negative 2 squared is 4, times negative 2 is negative 8, so I go down 8. So I get a parabola, something like that. For g of x, what shape is it? The v, right? The absolute value v. Where's the vertex for this one going to be? Negative 2, negative 4. Very good, right there. Is it going to open up or down? Up. This is a positive 3/2. On this side, what slope is it going to have? 3 over 2. So I go up 3 over 2 is right there. On this side, what slope is it going to have? Negative 3 over 2. And what I'm going to do is this. I'm going to change it to positive 3 over negative 2. So I'm going to go up 3, back 2 to get to that next point. And there is my parabola. I realize this is a little confusing. This is why we covered this stuff now. We'll go over it again at some other points. We have a few minutes left. Were there any questions off the study sheet looking ahead to the test on Monday? Everybody's good? Okay, so for the test on Monday, remember you can use your notes. Use your notes and your calculator for the test. There will be unlimited time. We're only going to take the hour and 15 minutes in class, but if you need more time, you can arrange at your site to do that. The biggest thing is it all has to be done in one session. So once you start it, you've got to stay and finish it is all. So with that, you guys have a great weekend. Homework 10, A, B, and C, of course, are due for Monday. Quiz 10 is also due Monday. Those will be due at 11:59 p.m. So if you absolutely have to let them go until after the test, you will still have some time to do them after the test by midnight that night, but I'll leave it up to you whether you want to do them first or if you want to wait. I would recommend doing them first just so you know you've done the quiz correctly and so you know you have those topics down. So anyway, yes, test is on Monday. You guys have a great weekend. Yes.
So I am going to be here Monday, but I do have to leave on Monday.
Okay.
I was wondering if maybe I could pick up and take my test at 11:30 instead of 12:30.
When I send it out, I will make sure they know that you can start early.
Okay. So I imagine B and LRC will happen?
Yes,
Yeah, okay. Thank you.
you bet. You do, thanks.